Assalamu alaikum warahmatullahi wabarakatuh. In this video, we will talk about factor affecting the rate law or the rate of the reaction. Okay, before we discuss what factors exactly affecting the rate of the reaction, we will go over the collision theory. So what is the collision theory? If we have two reactants like this one, this is the first reactant and this is the second reactant, and we have these reactants in contact with each other. So how they will form the product? So this theory just postulates that these reactants should collide with each other first. So we have a collision here, and these collisions will form a transition state, and this transition state is called the activated complex. So this is the place where we form this activated complex. So here we have the activated complex, and this activated complex just a transition state. It will help the reactant to break the bond between them and form the new bond where they will form the product. So if you form the activated complex, actually we will form the product. If we didn't form the activated complex or have less probability of forming the activated complex, so the forming of the product will be with this rate. Okay, so if we have the reactant here and they will form the activated complex, so actually they should have enough energy, and this energy is the difference between the activated complex and the reactant, and this energy is called the activation energy. So if they have higher energy, so they can form the activated complex, and if they can form the activated complex, they will form the product. So if we have the rate of the reaction will increase by increasing number of collisions. Of the number of collisions will decrease, so the rate of the reaction will decrease. Let's see how we apply this on the rate of factors affecting the rate of the reaction. So the first factors will affecting the rate of the reaction, concentration, of course, concentration of reactants. So let's say that we have two reactants here, A and B, and we have different cases here. This will talk about the liquid or aqueous solutions here. So we have 1 molar for each, and here we have 3 molar. Okay, so what is the difference? If the higher number of the higher molarity, it means you have number of moles, and the higher number of moles, it means that we have more particles. Okay, so here is less particle. So if you put the two substances in the first case with each other and the second one, so the higher the number of particles, it means they will collide more faster and the number of collisions will be higher. If the number of collisions will be higher, it means you have more probability of forming the activated complex. And if we can form the activated complex, it means that we can form the product. Okay, so the higher the number of the concentration, the higher number of collisions, and this will give a high rate of reaction. But when we are solving this question, we need to carefully look for the rate law. If he give you the rate law, let's say we have a reaction here, A plus B will give C, and he said that the rate law for this reaction equal to K multiplied by the concentration of A only. So the substance that would form or found in the rate law, this is the only substance which will affect the rate law. It means the change in the concentration of A only will affect the rate law. So when we adding more B or decrease the concentration of B, actually it will not affect the rate of the reaction because it's not found in the rate law. Okay. 2, surface area. When we are talking about surface area, we'll talk about solids. Let's take an example here. We will take this one, a piece of solid, let's say sugar. And again, we will take the same amount, but with pieces. And we will take the same amount, but as powder. What is the difference between them? Okay, the difference between them, it will be the area between the substance and the substance will react with. So if you put each one of them inside a glass of H2O, so this piece or this cube of water of sugar will only contact H2O from this area, which is the outer surface area for sugar. But here, all these pieces will be in contact with H2O. So it means that here we have more area would be in contact with H2O. And actually, if it's powder, so more area will be in contact with H2O. So if you are increasing the surface area, so increase the surface area will increase the area will be in contact with the other substance, it means we'll increase the number of collisions. And if we increase number of collisions, it means we could have higher rate of reaction. Okay, so it will be, if it's powder, so it will be having a higher surface area. And if it's having a higher surface area, higher number of collisions and higher rate of reaction. Okay, pressure. Okay, when we are talking about pressure, of course, we are talking about gas. So again, the higher pressure, what it means higher pressure? Higher pressure, it means higher number of particles. So we're having a higher number of particles. So if you have higher number of collisions, so we have higher number of particles. And if we have higher number of particles, it means we have higher number of collisions. And if we have higher number of collisions, so again, we could form the activated complex more easy. And if you form the activated complex more easily, so the rate of the reaction is higher. So we have higher rate of the reaction. Okay, number 4, nature of reactants. So, okay, so when we are talking about nature of reactants, we are talking about elements. Okay, and when we are talking about elements, we will compare between elements according to something called the activity series. So the activity series where all elements are arranged according to their activity, and the one in the top is the more reactive, and if you go down, this will be less reactive. So when we are comparing between two elements, the one with high reactive, this one will take, or the rate of the reaction of this element will be higher. So if you're comparing between potassium and maybe silver, so it means potassium is more reactive, so the reaction of this one will be higher rate. So the rate of the reaction for potassium comparing to silver, it will be with a higher rate. Okay, adding catalyst. So first, what is catalyst? Catalyst is a substance that increase the rate of the reaction without being consumed. It means the catalyst will never be consumed. So what is the reaction the catalyst does in the reaction? Okay, so if you have two reactants, A and B, and these two reactants want to react, but it's very difficult for them, they need help. And this help will be our reagent here, which is the catalyst. And the catalyst will help them to come together in contact and form the product. And after them, they will form the product, which is C, and the catalyst will be again free. So just like catalyst, just like a reagent, will help the reactant to come in contact with each other. It helps them to form the product, but he will never be consumed. He will be free, and he will never he is not a part of the reaction. Okay, he's just helping them to form the product, and then he will be the same. Nothing will change for the catalyst. So how the catalyst will help them to form the product? Okay, let's go for this graph again. We have the energy here, and we have the reaction coordination. Okay, so here's the reactant A and B, and again, to form the product, you will form the activated complex, and then you will form the product C, and this area is the activated complex. And we say that to form the activated complex, you should have enough energy, and this energy is called the activation energy. And this is the energy they need to form this activated complex. Okay, so what's the what the catalyst does here? The catalyst will give them an opportunity to form the activated complex with less activation energy. So it means the catalyst decrease the activation energy. Let's take an example. If the activation energy is, this one with yellow, is 200 kilojoules, and actually it's very hard for A and B to form the activated complex with 200 joules, so they will hardly form it, and it will be very difficult for them to form activated complex. But maybe in the presence of catalysts, they will need only 50. So it will be very easy for them to form the activated complex, and so the product will be formed. So the catalyst will give them another way to form the activated complex with less activation energy. Okay, the last one is temperature, and inshallah we will talk about it in details in a separate video. Okay, temperature first, increasing temperature. What do you need to know about temperature? It's increasing temperature, it means increase the kinetic energy. And if we increase the kinetic energy, so number of collisions will increase. And if we increasing number of collisions, so it means the rate will increase. Okay, but we need to know something here before we solve. The temperature is the only factor affecting the rate constant. Okay, and later, inshallah, in another video, we'll talk how the temperature will affect the rate constant. Okay, let's see questions. Okay, the first question here, we have this reaction. Okay, and we have the rate law for this reaction. Okay, so the first question, according to the rate law for this reaction, an increase in the concentration of hydrogen ion. So he will increase one of the reactant here. So before continuing reading the question, you will assume that increasing one of the reactant will increase the rate law, the rate of the reaction. Okay, but before we answering, if he give you the rate law, so you need to go back again for the rate law and check if this reactant, which is the hydrogen ion, is found in the rate law or not. And as we see here, the hydrogen ion is not here, so it means it will not affecting the rate. Okay, so increasing the concentration of hydrogen ion will not affect the rate. And again, if he didn't mention the temperature, so the K also will not be affected, so rate K will be also constant. So we have this one. So neither the rate or the value of the rate law constant is changes. So none of them will change. Okay, we'll have the same reaction, but in this case, we will decrease the concentration of iodide, which iodide, this one is the iodide I. So we will decrease the concentration of the iodide. So first, it's one of the reactant and it's found in the rate law. So if it's found in the rate law, it means it will affect the rate of the reaction. And if it's decreased, so the rate of the reaction will decrease. If it increases, the rate of the reaction will increase. And again, it will not affect the rate constant because the rate constant will be only affected by the temperature. So let's search where is the answer here. Okay, so the rate law of decrease and the value for the rate law constant remains the same. So this is the answer here. Okay, the last question. Okay, we have a sealed container and the whole two or first order. First order reactant means the rate R equals to K multiplied by A to the power of 1 multiplied by B to the power of 1. If additional moles of B are added, so it means that we increase this. So here he said that if additional moles of B are added, it means we are increasing the concentration of B. So keeping the temperature constant. If you're keeping the temperature constant, it means K is not changed. So K will not change here. It will be the same. Okay, what can be said about these, the reaction under these conditions? So first, we're increasing B. So this one should increase. The rate will increase and the K was the same. So we are searching where is the answer here. So we will see that the rate of the reaction will increase, but the rate constant will remain unchanged. So this is the answer here.